Hello friends, polynomial part 3, class ninth. This is the exercise, now I am solving exercise 2.5 and which is based on identities. So here there are 10 or 11 identities. So this 10, 11 identities I am dividing into two parts. In my first lecture, I'll explain first 5 identities and on the basis of that solve some questions, and in the next lecture remaining identities will be solved. Okay. So let us start the first this is exercise 2.5 of class ninth NCERT book. Starting from the identities, first identity is this is x plus a multiplied by x plus b is equal to x square plus a plus b into x plus ab. This is an identity. X square plus a plus b into x plus ab, and x plus a, x plus b. This is considered as identity number 1. First of all, I am proving it, that how it comes. So friends, nothing special in it, simply x plus a, x plus b, there are two terms in a bracket and both the terms are in a bracket. We'll multiply them. As we multiply, simply the bracket of 2 multiplication, first number of first bracket multiplied by second bracket plus second number of first bracket multiplied by second bracket. So that means it is coming, when I open the bracket, it is x square plus bx plus ax and plus ab. What does it mean? X square as it is, the like terms. Like terms are here too. X square is only a single term, doesn't have any like term. Plus, here there are two like terms, bx plus ax, taking x as a common, b plus a into x plus ab. So actually this is the result of product of two brackets is considered as an identity. So we'll have to remember this as an identity. If there are two brackets, first number is same but the second number is different, then we can write direct result x square plus a plus b into x plus ab. Okay. On the basis of this identity, I am taking one or two questions. So first question I am taking, suppose x plus 8, x minus 10. X plus 8, x minus 10. X plus 8 and x minus 10. Question is, by the way, in this entire exercise, there are two types of question. Number one, evaluate. Evaluate, that means the factor term is given and we are going to evaluate. That means we are expanding the term. Second is find the factor. That means the expanded term is given and we are going to find the factor. Okay. So here factor term, what does it mean? That means the terms which are present in a bracket form is factor term. So I want to evaluate it. The question is evaluate. Okay. Evaluate, that means we are going to expand it with the help of identity. Okay. X plus 8, x minus 10. Using this identity, because you can match the first bracket x plus 8, second this is x plus a, x minus 10, it is x plus b. Okay. So when I am going to expand it, simply x is equal to x, no change in it. But here in place of this a, x is equal to x, a is equal to 8 and b is equal to minus 10. What does it mean? I'll write first this identity. X plus a, x plus b is equal to x square plus a plus b into x plus ab. And in all those questions, it is clearly mentioned that using identities solve the question or evaluate the question or factorize using identities. So I am using an identities. X as it is. In place of a, there's a 8. X as it is. In place of b, there's a minus 10. Friends, minus 10, what does it mean? Where there's a b, we will have to put minus 10 because the identity having only the plus format. Okay. This means x square plus in bracket a plus b. A, that means it is 8 plus b minus 10 into x plus ab. A is 8 and b is minus 10. So that means it is coming x square plus 8 minus 10. It is minus 2. Minus 2x and 8 10 ja 80 with minus sign. Minus 80. X square minus 2x minus 80. This is the evaluation of this question. Is it okay? Second type of that means using the same identity, and I want to take another question. Another question again, it is evaluate, and I am taking two numbers, suppose 95 multiplied by 96. 95 multiplied by 96. I am going to evaluate this 95 multiplied by 96. Okay. Now let us see, because we are using identity, and identity I have x plus a and x plus b. In place of plus a there could be a minus, there could be minus, there's no problem. So friends, 95, if I want to write 95 in a different term, that means 95 can be written in the form of two terms, addition of 2 or subtraction of 2. Okay. So I can write here 95, that means it is 100 minus 5. 100 minus 5 becomes 95 multiplied by 96, because our identity is the first term is always same. So here is 100, that means here also I have to write here 100 minus 100 minus 4, which becomes 96. So first of all, to convert into this format, 100 minus 5 multiplied by 100 minus 4. After that, using identity, x plus a, x plus b is equal to x square plus a plus b into x plus ab. Now let us see, x is equal to 100. Where there's x, we can put 100. In place of a is equal to minus 5 and b is equal to minus 4. Three values, x 100, a minus 5, b minus 4 will be substituted in this identity. So it is coming 100 plus a, that means it is minus 5, multiply 100 plus b minus 4 is equal to x square. The value of x is 100, 100 square plus sign. See, when I write this step, my focus to this identity, x square plus sign as it is, in bracket, there's a bracket, a plus b, the value of a is minus 5 and minus 4. Outside x, x means 100, plus a minus 5 multiplied by minus 4. So that means 100 square, 100 multiplied by 100, it is 1 with 1, 2, 3, 4, 0. Minus 5 minus 4, it is minus 9 multiplied by 100, and plus minus 5 multiplied by minus 4, since both the signs are negative, so this is plus 5 4 ja 20. So now it is coming 10,000 minus 900 plus 20. 10,000 minus 900 plus 20. Then now you can see that the three terms here, 10,000 with positive sign, 20 with positive sign, and 900 with negative sign. So first of all, I am adding both the positive terms. 10,000 plus 20. So it is coming 10020. 10,020 minus 900. And 10,020 minus 900. 10,020 minus 900. Result is 0, 2, 10 minus 9, 1, and it is 9. 9,120. 9,120. So that means the answer of this term 95 multiplied by 96 is equal to 9120. And we can verify this answer by simply multiplying 95 multiplied by 96. Okay. So that is the second example which is based on this identity. So friends, this is identity number 1. Now I am taking second identity, and second identity I am taking, that is x plus y and x minus y. X plus y and x minus y. So I think you are aware of that. A plus b, a minus b, that is a square minus b square. Okay. So using this identity, I will take some questions. First of all, I am proving the identity. Second one, x plus y and x minus y. That means it is x square minus y square. That is identities number 2. I am writing here, actually this, here I am making the list of identities. Number 1, it is number 2. X plus y, x minus y. So if I will multiply both the bracket, so I think there is no problem in it. Look at this. X plus y, x minus y. Simply I will multiply two bracket. This x, which is multiplied by x minus y, second term plus y, multiplied by x minus y. So what it will be? X square minus xy plus x multiplied by y. Again it is xy minus y square. Minus xy plus xy. It is cancelled. X square minus y square. So that is the direct result, x square minus y square, when we multiply these two brackets. So that is considered as a second identity. Was one example I am taking. Suppose the question is, I am taking question y square plus 3 by 2. Now y square plus 3 by 2 multiplied by y square minus 3 by 2. Y square plus 3 by 2 multiplied by y square minus 3 by 2. Using second identity, expanded form is given. Factors are given. We are going to convert into the expanded form. Factors form are given. Factors form, I told you, these are the forms in the form of bracket. Okay. So look at this. Using this identity, y square plus 3 by 2, and second is y square minus 3 by 2. So I am writing an identity. X plus y, x minus y is equal to x square minus y square. Right? First we compare the terms. In the first bracket you can see there are two numbers, sign is plus. Second bracket there are same two numbers, sign is minus. That means this identity can be used. In place of x, x is equal to, we have to treat it as y square, not y. X is equal to y square. Y is equal, and x is equal to y square. Y is equal to 3 by 2. Y is equal to 3 by 2. Actually both the things, x is equal to y square and y is equal to 3 by 2. So you will treat this, since here it is given that y square, therefore you can consider this is suppose capital X here. Here I am taking capital X, so that there should not be any type of confusion. Now is it okay? So capital X is equal to y square, and y is equal to, small y is equal to 3 by 2. Okay. These two values will be substituted here. In place of x, y square plus y 3 by 2, bracket close. Second, capital X, again y square minus 3 by 2. You can see this is the left hand side term. That means this is a question. And its value is x square minus y square. Capital X square. Capital X square, what does it mean? Y square whole square. Capital X square. Capital X square. So y square whole square. That means squaring on both sides. Minus y square. The value of y is 3 upon 2 whole square. So if I will solve this step, y square whole square. Loss of exponent says the power to the power. That means the multiplication of two powers. So y to the power 2 2s are 4 minus square of 3. 3 3s are 9 upon square of 2. 2 2s are 4. So that means the solution of this term is y to the power 4 minus 9 upon 4. Okay. So this is the use of second identity. Now third identity I am writing, that is, it's well known identity, you are aware of that. It is x plus y whole square. And x plus y whole square is equal to x square plus 2xy plus y square. Third identity, identity number 3, x plus y whole square. That is x square plus 2xy plus y square. So 3 as well as fourth. Fourth also I am writing here because there is only a change in the sign. X minus y whole square, if it is, then x square, in place of plus 2xy it is minus 2xy and plus y square. Friends, as per my past experience, I can tell you that the boys, they will make mistake in these two identities, and especially in this format. When x plus y whole square is there, all three terms are positive. First term square plus second term square plus 2 multiplied by first term and second term. That is a plus identity. But minus identity x minus y, first term whole square plus second term whole square. That means both the terms which are having square, they are always positive. And it is 2 multiplied by first and second having a minus sign if there is a minus. So you'll keep in your mind, if there is a minus sign, this middle term will be negative only and these two will be positive. Okay. Again, I am proving this identity. I am proving x minus y whole square. Because if I prove this, third automatically proved by yourself. There is no problem in that. X minus y whole square. What does it mean? X minus y whole square, that means x minus y multiplied by x minus y. Because whole square, that means I can write x minus y multiplied by x minus y. Is it okay? Two terms, same sign, everything is same as x minus y, x minus y. Multiplication of two brackets. First term multiplied by second bracket. Minus y, x minus y. This means, again open the bracket, x into x, it is x square, minus x into y, xy, minus y into x, again it is xy, minus y multiplied by minus y. It is plus y square. And that means x square minus xy minus xy, both the terms are like term. Nothing is here, it is 1, it is also 1. Same sign, minus will be added, minus 1xy minus 1xy, it is minus 2xy. And plus y square. So friends, this is the result, x minus y whole square is equal to x square minus 2xy plus y square. Same as if there is a plus sign, so they are positive and all the terms are coming in the form of plus. Okay. So these are the identities. Actually, these are the direct form. When we solve the left hand side portion, after solving whatever the result is coming, if I will write direct result, it's considered as an identity. So these are 4 identities here. Next one are these 3 and 4. Now I am taking 1 or 2 questions on the basis of these identities and solving them. So the question I am taking 9x square plus 6xy plus y square. 9x square plus 6xy plus y square. 9x square plus 6xy plus y square. Okay, this is a question. Factorize. Factorize 9x square plus 6xy plus y square. Because this is the expanded form of the terms, we are going to factorize. That means we are converting the term into the form of brackets. Okay, so first of all, we'll have to understand that this is the part which is equal to or which can be compared to which one of the right hand side part. You can see here number of terms 1, 2, 3. Here number of terms 1, 2, 3, 1, 2, 3. So I think both of them we can use any one of the identities. Since all the signs are positive, here all the signs are positive. So definitely we will have to use this identity number 3. So first of all, I am writing identity number 3. X plus y whole square is equal to x square plus 2xy plus y square. Okay. Here, because this is the term which is in the form of question. So first of all, I would like to convert this term into the form of standard form of this form. X square plus 2xy plus y square. X square. This is the question. X square, that means the first term is 9x square. 9x square, we have to write this into the form of whole square. How to write in the form of whole square? 9 can be written 3 into 3. So may I write 9x square 3x whole square? 3 3 is 9 into x square. 9x square plus, now I am not disturbing this term, writing as it is 6xy plus it is y square. Is that okay? First term square plus it may be 2xy and it is plus y square. So from this step we have got one thing, that this is the value of x which is equal to 3x and y is as it is y. Now let us see 3x whole square plus, try to convert into the form of 2xy. So I am writing here 2. In place of x this is 3x. In place of y it is y and plus it is y square. Now you can see x square plus 2xy plus y square. Let us check this step is properly matched with that or not. 2 3 is 6xy. It is also 6xy. 3 3 is 9x square and plus y square. Yes. Now the right hand side term is same as exactly x square plus 2xy plus y square. So this is also x square plus 2xy plus y square. And what is the meaning of this term? The meaning of this term, that means if any term which is in the form of this expanded form, we can write x plus y whole square. And x plus y whole square, that means this first term plus last term whole square. So here the first term is 3x plus last term is y, its whole square. And 3x plus y whole square, what does it mean? 3x plus y in the first bracket as well as 3x plus y on the second bracket. So these are two factors of this expanded form. Okay friends, one more example I am taking now. Next question, again factorize the term and I want to take 4y square minus 4y plus 1. Suppose 4y square minus 4y plus 1. And again the question is factorize. How to factorize? Let us see, this is the extended form, and extended form to be matched with this identity number 4, because on right hand side there is a minus sign. One minus sign here, here is also minus sign. Okay, so I using identity x minus y whole square is equal to x square minus 2xy plus y square. Now the term is 4y square minus 4y plus 1. So friends, again 4y square It's a term we want to write in the form of whole square. 4y square can be written 2y whole square. 2y whole square. Minus 4y I am writing as it is. Plus 1. Since 1, if I write here 1 square, it also 1. So in place of 1, may I write here 1 square. There's no change in the meaning. You can see this is x square minus 2xy plus y square. So here one clue we got it. That is x is 2y and y is 1. So I am writing here 2y whole square minus 2 into x. That means it is 2y and y, that is 1, plus 1 square. X square minus 2xy plus y square. See, 4y square, 2 2s are 4y and plus 1. And that means it's the left hand side, x minus y whole square. X means first term, 2y minus 1 whole square. And 2y minus 1 whole square, that means 2y minus 1 can be written 2y minus 1 multiplied by 2y minus 1. So it is 2y minus 1 and 2y minus 1. This is a factored form of it. Okay. So these are 4 identities. Now I am taking the 5th identity having 3 terms. Fifth identity is x plus y plus z whole square is equal to x square plus y square plus z square plus 2xy plus 2yz plus 2zx. Okay. So friends, the 5th identity is, this is x plus y plus z whole square is equal to x square plus y square plus z square plus 2xy plus 2yz plus 2zx. This is identity number 5. X plus y plus z whole square is equal to this. Nothing special to prove in it. Again, x plus y plus z whole square. That means whole square x plus y plus z. Multiplication of 2 bracket. So when I multiply 2 bracket, first term of first bracket multiplied by x plus y plus z plus second term of the first bracket multiply x plus y plus z plus third term z multiplied x plus y plus z. This is the rule when we multiply 2 brackets. So all the terms of the first bracket which is to be multiplied to the second bracket one by one. First I have taken x, second y and third is z. For opening this bracket, the rule is this x is multiplied to all the terms. So it is like term x square plus xy plus xz plus yx or xy plus y square plus yz plus zx or xz plus yz and plus z square. So the next and last term is x square plus y square plus z square, xy and xy. There are 2 terms. So plus 2xy plus yz. It's also 2 terms. 2yz and zx and zx 2 times. So 2xy plus yz plus zx are xz. This is the extension part of it. So that is identity number 5. Using this identity, you are taking a question. Suppose the question is x plus 2y plus 4z whole square. What is it? X plus question x plus 2y plus 4z whole square. X plus 2y plus 4z whole square. And what is the question? Evaluate. evaluate the following. So when I am going to evaluate, you can see that the number of terms 3 in a bracket, sign is plus, number of terms 3. This is the extensor. First of all, I am writing identity x plus y plus z whole square is equal to x square plus y square plus z square plus 2xy plus 2yz and plus 2zx. So friends, x is as it is, no change. In place of y, there's a 2y, and in place of z, here is 4z. So nothing I have to do, only in place of x, y, z, I am going to replace these values by x replaced by x, y replaced by 2y, and z by 4z in this term. So let us see what is coming. X as it is, in place of y, 2y, place of z, 4z whole square is equal to x square as it is plus y square. The value of y is 2y, so 2y whole square plus z square, 4z whole square plus 2xy, 2 as it is, in place of x, x, y, that is 2y, plus 2yz, 2y, 2y, and z, 4z, plus 2zx, z, 4z, and what is x? That is x only. So that means the extended form of this is x square 2y whole square. 2y whole square, that means 2 2s are 4, y square. When I open the bracket, 4y square plus 4 4s are 16, z square plus 2 2s are 4, xy plus 2 2s are 4, 4 4s are 16, yz, and plus last 2 4s are 8, zx. 8 zx. This is the extension of this factorized term x plus 2y plus 4z whole square. If I will take another question like 1 upon 4x minus 1 upon 2y plus 1 whole square. This question I am giving you for solving it. 1 upon 4x minus 1 upon 2y plus 1 whole square. We are having this identity only, x plus y plus z whole square. Not to worry about that. In place of x, 1 upon 4x. In place of y, in this identity, we have to put minus 1 upon 2y. In place of y, minus 1 upon 2y. And in place of z, it is 1. We'll extend it, substitute the value, and we'll get the answer. Okay friends, so these are the 5 identities, and the remaining 5 identities which are left, that would be discussed in my next lecture.